Good evening, everyone. It's 7 o'clock. Let's get started. I give you the homework. Actually, I give you the real question from AP Computer Science and asked you to do that. Right now, I only get two submissions, and both have some have some issue with the code. I really want to review those two submissions, trying to help you guys, and uh, and I do not want you to be shy or feel embarrassed because you are doing it not correctly. Because in the future, my class for the AP Computer Science actually is trying to find the weakness of your work in order to help you improve. First, let me get Daphne. Can you share your submission, and then we review your code, and then I can point out the issue, and then we can learn from it. Do you mind about that, Daphne?
Yeah. Wait, can you repeat what you just said? Sorry, I didn't hear.
I'm sorry. So I want you to share your homework submission for this week, and
Oh,
let's review the code, and then we can help improve it, and also help the students who have not submitted. So for anyone, if you do not submit the homework, and for an AP computer science class, I think you're up to a level. You don't need me to talk about that you need to do homework. I will just assume that you do not know how to do it. All right. So can you just walk through it?
um, yeah.
Just those two methods.
The get value at method. It has two parameters, and then I use the for each loop. And if um the parameters and then for the for each loop, I went through like the array list of the entries, and then if the column for or they I used the get column method to get the column value, and if it matched the parameter and if the row value also matched the parameter, then it would return the value or the object's value. Otherwise, it would return 0 for this method. And then for the remove column method, it passes in an integer parameter column, and then I used a loop, but I started from the end because when you remove an entry from the array list, the other elements will shift up. So sometimes like one of the elements will get skipped if you use a loop from starting at 0 and going up and increasing. So in the for loop, I first tested to see if the column value at a given index was equal to the parameter, and if it was, then it would remove that element. Otherwise, if the column number at a given index is greater than the column number, which means that then in that case you would have to decrease the column value by 1. In that case, I created a new object, and this object it has the same row number, but the column number is decreased by 1, and the value is still the same. And then I set the value at this index to this new object here, and then yeah, that's it.
Okay, I think you have a. Oh, I still want you to share it. I think you have a very clear idea. Logically, you want to get the requirements done. Um, and as I mentioned in your homework submission, let me ask the class: do you guys see any issue in this solution for remove column? Let me ask Jin Kang first. Jin Kang, do you see any problem in this code? Jin Kang, you hear me?
Um, well, this, um,
All right. How about you, Hagen? Do you see any issue? Hagen.
I'm not sure if there's any issues or not.
Okay. So Sophia.
I feel like I should be like one down since it be the index would be out of bounds if it's just that I recall.
Okay. So Stephanie, I wanted to point out. I'm not trying to put you under the spotlight because I see this code. I I wish that when I do this, it can help you, also help the class. So here you see one requirement we have not done is that you need to reduce the column number. So I do not see it here. That's number one. Number two, the index I actually is for columns. How many columns? But you use it for interest. Interest is a list. It has all those items that has a value which is not a zero. So that is mixed. So if you use this I, if for your class you may only have 2 items, but you have 4 columns, then you definitely will get a problem. Here. You will get an exception. So this I index here, you see this I index here, is only for how many columns? It's actually not an index for the interest. So that's the 2 problems we have in the code. I really want you to go back and think about that. If you can correct it, that's great. Thank you, Stephanie. Sophia, can you share your work? I think the first one it's good, perfect because I think you got it. And how can you talk about the second one?
For the second one, I decrease the number of columns. Then I go through each entry, and if the column number is over the input, then I just replace it with a new one that's one less. And if it's the same as the input, it just gets removed.
Okay, this code logically, it looks great, very neat, very straightforward, and good. But actually, it does not work. And the reason why it does not work, so Sophia, I want you to stop sharing because I really talking about this. I think you may not in this class before, so that's why you did not get this information. I really did not talk about in our Java level 1, level 2 class. Okay, so why you have a problem here? So I wanted the class to remember it, okay? So I talk about this. Access the element in the array using index, okay? So, and they slide up as well. So let me just go a little bit. Okay, access the element in the array using index and the square bracket, and then you have the enhanced for loop, and it looks like this, and it is exactly what Sophia used, but there's a limit on this one. There's a limit on this one. So with this loop, you cannot change I here in the loop. Why? Because I mentioned I is just a copy of the item in the array. It's only for you to do reading. You cannot do any change. And I also showed you this again, this example. And if you have a Java class, I really want you guys to go ahead and run again. Then I have another example I will show you, and I want you guys to try, okay? So you guys go ahead, copy this code and put it in your main method and run it. And you see I use for loop here, the enhanced for loop, and I did increase I. Okay, that means first time I is 2. I increase it, it should be 3. All right. Second time I is 5. I increase it, it should be 6. Then 7, and it increased by 1 should be 8. So when you print this out, you did see they changed it. They are changed, but when you print out again, and you see what happens. Can you guys do that? Are you getting 368 or you get 257? So what did you get, Sophia?
257. 257.
You still get 257, right? You did not really change it. And this may not be obvious to you because you see the I is changed. Now why this list is not changed? So I mentioned because this actually get a copy of it. It's not the real item. It's just a copy of the item. And then Sophia, your solution actually is a step further. And I need to show you another example. Then you will see your code really doesn't work. So let me show you. So I have an example like this. I have an array list. It is course. So I have 1, 2, 3, 4. I have 4 cars, right? Then I print out the 4 cars. And then I put an index here. Now I'm doing a loop using the enhanced for loop. If it is 2, I wanted to remove that car. And that should be forward, right? It should be removed. But when I print it out, and you see what I got. You see, when you do this output, you get 4 items. When you do this output, you still get 4 items. You are not removing it. You are not removing it. So let me just do one more thing to confirm. Okay. So let me put it here as well. And then let me run it. It's still 4. Oh, sorry. Let me try this. Let me try it. See if this time it works or not. Okay. So then, Sophia, yours is corrected now. Yours is corrected. So this does remove it. Even it's a copy, it is removed. So can you share your code to me again?
I was just changing it, but yeah.
So this is a copy. Okay, I see that. Then if this is your original copy, then your original code. Let me take a look at that.
I changed it to this. This is my original code.
Yeah, that's the original code. Then looks like it's that. It's okay, even though it's a copy.
Yeah, this is it. My original one. It didn't. It'll work.
I did not test your line 47. I did not test it based on the theory, entry will not be itself. It's just a copy. It is just a copy. So the removal, it works already, it's against that rule. I need to double check that. I need to have some code to change it to check that. Okay. Let me just do it on my computer, and then let me see it. So can you stop sharing, and then let me just share my. So I wanted to do it with you guys together, so we can see the result. All right. So let me just do this. So let me just do one more thing here. If it's equal to 1, then it means for change it. A core equals to what? So now let me just print it out. All right. So looks like this still stays. You say you cannot change the list itself, but this one that's get removed. So you just need to make sure you need to change that code, Sophia. This part. So you wanted to reset it, you need to change that. Okay, but the remove one still works. You see the point, Sophia? So let me come to your code, I believe. Okay, you see this one, it will not help you to make a change. You are not going to change the interest. But this part, it works. You can remove it based on this example. You see here is still print out the BMW. All right, so I hope you guys get this one and really, um, get the code to work. I really want you guys to, do this homework. That does help you. If you do not do it, of course, if you do not take the exam this year, you still have time. Or it will be very hard for you guys to write code. You see, this is the real exam. It's the real exam question, and you need to do it within that time, and you need to write it down. It's not using Eclipse like this. You're not using Eclipse to do it. You have to write it down. With Eclipse, you can still get some help. It can tell you this syntax is wrong, something like that. So you need to really be very familiar with coding. So you need to do it. All right, so let me move on for today's topic. I'm going to do it quickly then. Inheritance. I think conceptually, this is very straightforward to us because we already learned a lot about Java. So let's just say you learn how to manipulate programming without altering existing code by using subclasses to create a hierarchy. So you have like a parent class or superclass and then the child. So how much does this weigh? 5% to 10%. It's about 2 to 4 questions. And it's also in the free open response questions. Right? So what are you tested on this? Using common attributes and behaviors to group existing objects into superclasses. Okay, you can create a superclass and defining and overriding methods within subclasses and subclasses. Creating reference using the inheritance hierarchies. So this part may be difficult, okay? What does it mean? When we talk about the constructor, right? And you need to understand the hierarchy, okay? Associating subclass objects with the subclasses to create a polymorphism. And this one, sometimes is also very hard. I think there are some questions that are very confusing to you, and we need to do some of them to understand it better. Okay. So inheritance put in the simple ways that the child class has all what the parent class has. Using extends in class declaration to make a class the child of the parent class. You may get a question ask you to write a class which is the child of another class. You may get that. So we asked you to write a class before when we talk about the class. So you need to remember, if you wanted to do in the child class, you need to use the extends. One class can have only one parent in Java, okay? You only have one inheritance. Though one class can implement multiple interfaces, okay? So you implement an interface, you extend a parent to a child. Okay, that's a keyword you need to keep in your mind. So in inheritance, constructor is not carried down. Okay, we can use the soup keyword to refer the parent class. What does it mean? So if you wanted to refer some members in the parent, you use the soup to refer it. Just like if you wanted to refer this instance of the class, you use this keyword. Okay. The child can have its own new attributes or methods. It can also override those inherited from the parents. You can also overload the method by creating a new one. Okay? The parent has a method like this. I will create a method with the same name, but different signature. So again, let me ask you, what consists the signature of a method? Do you still remember? Hagen, do you remember?
What was the question again?
What consists the signature of a method? So the signature of a method, when we talk about the signature of the method, so what are the components of it? Okay, it's the name of the method and the list of the parameter. If you change the order of the parameter, you change the numbers of the parameter, you change the type of the parameter, they are all considered different. Okay. All right. So the exception is not considered part of the signature. Inheritance, when override method, we use the annotation override. We do not need to provide Javadoc comments for the overriding method because it will get those from the parent. Okay? You may be asked to write some Javadoc in your free open response questions. Okay, so you need to remember how to do that. So relationship of a superclass and a subclass can be interacted. For an example, if C is a subclass of B, and B is a subclass of A, okay, then C is also a subclass of A. So object is the root superclass in Java. So object is the parent of all. It is the parent of all. So that's the inheritance. And then let's learn about the polymorphism. What is the polymorphism? Polymorphism is that you have multiple types for one object of a subclass. Okay, this is at the object level. In the previous example, we can legally write this code. Here, C is of type C. B uses C is of type B. C is also of type A. With the inheritance, and when you create a child class, and you keep creating a child class, and then you say C can be an object with polymorphism. It can you can consider it a type of C, a type of B, and the type of A at the same time. Does this make sense? At least this doesn't make sense. Give an example. Give this example here. C is subclass of B and B is subclass of A. Then C is also subclass of A. So that's why you can do it like this. Okay. I think the hard part is the next one. A subclass can be safely casted to a superclass, but the superclass is not necessarily true to be of a subclass. Trick on static methods in a superclass, even after it is overridden in the subclass. Why it is a trick? We did not talk about this in Java level 1, Java level 2. Okay, I really want you guys to be aware of this. So let's do this. So you see the example. A, C, new C. When you create a C, you actually see it's a type C, right? But actually in the Java, you also, when you declare it, you see it's type A. It is type A, okay? So this is the tricky part. So it's very hard to understand if you do not pay attention, you do not think about it, why it is hard. You see, static method is in A, is actually used when you use C, the static method, okay? So if when you use C dot, that method name, what you actually call is that method defined in A. Okay? For the non-static methods, then if you do it here, if you use C dot something, and you are actually call that method the instance in C. The one in C is used. Does this make sense to you? Are you lost?
A bit.
Okay. So how about you, Sophia? You lost?
A bit as well.
I cannot hear you.
A bit as well.
How about you, Daphne?
I understand most of it, just a few parts I'm confused, like the static methods. But other than that, I think I'm okay.
So how about you, Jin Kang?
I think yeah, that too.
Okay, so let me just explain this a little bit. You see, when you create a C here, actually it's a new type of C. Okay. You use C's constructor to create a C. So if you call C's method, C dot method, actually it use all the method defined in class C. The only problem is that if this method is a static method, and this static method is also defined in A. So that means A has a static method, C inherited it. And even if you override that static method, when you use C dot the static method, you call as static method because to your application, when you declare C, you tell the system C is of type A. So that's why the static method is a class method, class level method, right? It's not an instance type. It is a class type method. So that is why as a static method is used. Does it make sense? Because when you declare C, you tell the system C is of type A. So that's why when you use the static method, you use that version in A. But when you use non-static method, when you create C, actually use C's constructor to create it. So dynamically, C is of type C. So if you use a non-static method, then the version that defined in C will be called, will be used. So that's why I say this the most hard, or we say the hardest part, okay? It is the hardest part for today, for us to understand. I want you guys to put a yes in the chat window so I know that you get it. Then I can move on. Good. I got one answer. 2, 3. Again, you have any question? Yeah, so if I wanted to give you an example, I really do not have an example of parent class and child class here. But when we get into level 2, okay, the session 2, I can do that. I need to prepare that to help you understand actually, you know. I need to have like 2 classes and then different methods in the classes and then extend it and then make it like 1 or 2 methods static. Then I can use it. Then you can see the result. Okay. So the logic is that to the application C's of type A. So that's why if you use a static method, because a static method is class level, so you use AS version of that method. But if you use non-static, because C is an instance of type C, because you use C's constructor to do it, then you use the version in C. I will try to get some example to help you. You can also read more. The polymorphism. Yeah. Okay, good. So let's just move on. Okay, so this is just the explanation I mentioned. For variable C, A is the type. It is declared as, we call it it's a static type. C is the type of that. Its constructor is called. So we call it, it's a dynamic type. We call it its dynamic type. So this determines the method call as we see in the previous slide. Okay. All right. So let me just get to the last one. I think this concept, I did not explain it in the Java classes as well. I want you guys to understand this one. As we learned, the object is a subclass of all. We wanted to look at the 3 methods it has: hash code, toString, and the equals. You see, when we use operator equal, we see it's in a reference comparison. If you use the equal method, it's the content comparison. So let's just dive into it, see more about it. Okay. The hash code method returns what is known as a hash code. It's just a string, okay? And the integer, okay, it's an integer that is used to represent the memory location of the object. That's a hash code. It represents the memory location of the object. This is usually based on the properties of an object, and any two objects with the same properties should have the same hash code. Should have the same hash code. Okay, this is a bad definition. So if you use hash code method, it will returns an hash code that's an integer. It is used to represent the memory location of the object. Okay. Usually this is based on the properties of an object, and any two objects with the same property values. With the same property values. Okay, let me just do it that way to make it more clear. Should have the same hash code. That's why when you use equal. So the equal method determines whether two objects are equal to each other based on whether they have the same properties or not. So if two objects are determined to be equal, then they must have the same hash code. Right? This is just a concept. But this is just a concept. So help you understand what is a hash code and then what is equal. So how should you implement it when you implement equals? And that is why you see equal will return negative value, positive value, and a 0, right? If you use hash code, and then the hash code is an integer. Or compress, okay, that's compress. Okay, so you know it for the object when you do equals, it's really based on the hash code, and you wanted to implement it. You wanted to implement it. Your own version of equal. Okay. So the toString method returns a string representation of the object that the method is called on. By default, the method only returns the object name and then an @, and then the hash code. So usually you wanted to override this one to return useful data. If it's a string object, you really wanted to just return the string literal, right? You do not want to just return like a array list. You just return a array list. You wanted to return something more useful, so you wanted to override that one as well. So that's these three things, and that's come from object. Come from object. Okay, and the object is the parent of all. So all the objects, or all the classes you define in your application will have those methods. Let me just show you, okay? So if I use course, put a dot here, you will see hash code, right? And you will see toString. And you will see hash code, right? And then you will see equal. This all come from the object that defended that. All right, hopefully this makes sense to you. So let me just move on and trying to finish the rest of it for today. We have 15 minutes, see how far we can go. Recursion, or okay, recursion, you will work on solving larger problem by solving smaller, simpler version of the same problem using recursive methods. So this is the weight, 5 to 7.5, 2 to 3 questions, okay? So you need to know how to execute in recursive methods, searching and sorting using binary search and the merge sort algorithm. Okay, we learned the insertion sort and the selection sort. We did not talk about the merge sort because merge sort we wanted to use recursive to do it. So that's why we talk about it here. And so I want you guys to do some reading after the class on merge sort. So recursion has 3 important features. A base case that returns a value. In the body of the function, it will call itself. Okay. In the body, it will call itself. The recursive call will shrink it in its parameters value so it can reach the base case. That's 3 important features of a recursive solution, okay? Recursive function. So all recursion routines can be written in iteration or loops. So recursion will be slower and use more memory because it has to stack every call in the memory. You do not know the answer until you reach the base case. So that's why they are all stacked in the memory until you reach to the base case, then it comes back to compute it. So that's why it is slower and it costs more memory. But logically or mathematically, it makes more sense. Okay? It gives you an idea, oh, I can solve the problem in its simpler version. All right? So let's move on. Nothing strange here, okay? So merge sort. I don't know if you still remember what is the insertion sort, what is a selection sort. All right? Selection sort, you consider the left side is already sorted, but of course you start from 0. Then you loop through the rest of the list and find the biggest or find the smallest, put it in the left-hand side. So then you go to do the next one and find the smallest and put it there. So that's the selection. Insert. You consider the left-hand side sorted as well, but you really wanted to swap the position of the first 2. Swap the position. If it's not, then put the third one in and swap the position if they are not self-sorted. So that's the insertion sort, okay? And this is the merge sort. Merge sort is the divide and the conquer algorithm that was invented by John Newman, okay? It is a top-down merge sort approach is a methodology which uses recursion mechanism. So that's why we talk about it here. It assumes in the one item list is a sorted list. Think of this as the base case in a recursive function. So if your list only have one item, good, it is sorted. So that's the base case. So now if you have more, what do? You just do it. You just split it. Just split it. All right. So I will have a diagram to show you why it works that way. So therefore, you start splitting the list into two until all lists are a single item list. You then merge them in an ordered list. You then merge them. So that's why this is called a merge sort. And let's see the diagram on the next slide. So what does it mean? Okay, you see this is your original list. And you split it, and then split it, and then split, and until at this level, it's a one item. Okay, now you merge this one, and then you sorted them, and then merge this one, you sort them, and then merge this one, you sort them, and then you do not have anything to merge, keep it. And at this level, you merge it again and sort it, merge it again and sort it, and until you get the sorted list. Right? And this is the code and merge sort. That's the start, that's the end. And if start less than end, you just split it. Just split it. And once you split it, okay, then you say this is, you call the merge sort again, call merge sort again, then you merge it. Then you merge it. So this merge sort eventually will create a single item list for all the items in this area, because you keep, okay, you keep split it. Okay. They eventually get one, but now let's take a look at the merge part. This is a recursive call, okay, and then the last part is merge. So let's just come back to merge. So this merge sort, that's the code, okay. So this is how do you do the merge, and you create and once you have that, you have the start right, you have the middle one, and then you have the end one, then you have the area, and now you do the merge. When you do the merge, you see you create a temporary one, and here you just check if they are if that one is large, you store it there, and then you just do this and arrange it, and then finally you will get them a sorted list. And I can give you this code, and you can take a look at that. So you say you just compare here, okay? So if it's if you just compare if they are large or small, and then you just try to store them there, and then make it a sorted one, and that's the code. I can give you this one so you can use it, help you understand that. So Let me give you this part. Give you this, okay. So you say you would try to traverse both areas in each iteration and add the smaller ones of both elements in the temporary one. And then you add the elements left in the first interval, add the elements left in the second interval, and then compare these two. Okay. And then you see if it is sorted or not. So let me give you this recursive function as well. Okay, so that's the top down. The bottom up merge sort approach uses a iterative methodology. It starts with a single element array and it combines two adjacent elements and also sorting the two at the same time. The combined sorted arrays are again combined and sorted with each other until one single unit of sorted array is attached. It's achieved. So that's this part. Okay. Now from bottom to up. So you just merge these two adjacent one, and then merge it, and then eventually get to it. That's the bottom up. Okay. So I want you to review on selection sort and the insertion sort. Selection sort is to find the smallest and swap it with the leftmost one. It is an in-place comparison based algorithm in which the list is divided in two parts. The sorted part at the left end and the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list. So that's the selection sort, okay? The insertion sort works as follows. Assume the first element is already sorted. Select the second element, insert it before the first element, or keep it in place to make the first two elements sorted. Then select the third element and insert it so that the first three elements are sorted. Repeat until all elements are sorted. So that's the insertion sort and the merge sort. So you just split them until they are in one item list. Then you merge them. When you merge them, you sort them. Okay. So then this quiz. I don't think you have time to do the quiz. So I have a string my test me now. Please write a recursive function to print out every character of my test. Do not use a loop. How to do that, right? So I don't think you have it. So okay, so I think today is the last class for our session 1. Session 2, we will spend the entire session. We'll spend the entire session 1 on review. I try to cover all the topics that will be tested. All the topics. The purpose is to cover what will be tested. It is a knowledge session. The session 2 is a practice session. I will already ask you to do work, and then we review the work. And then if we see some weakness, and then we need to improve it. Okay, we will spend the majority of time to do exercises. So we will find our weaknesses, and then we will improve our skills. I have a lot of quizzes, questions for you. So you can do those and we can do it together. Okay, so that's all I have for today and for the entire session. Let me see. Miss He is here, so let me stop my recording and then let me turn the class back to Miss He.
Yeah, thank you, Dr. Yan.